This is an audio description for GCSE Geology, Theme 3, page 5, Crystal Form or Habit. Minerals can have a distinctive shape. This shape is created by the atomic structure of the elements within the mineral. The way it's put together can create a distinctive shape for some minerals if they can grow without restrictions. This audio description describes some of these common shapes. The first crystal form is cubic. With this crystal form, the sides of the crystal are roughly square, so they have even length sides. The crystals themselves have 6 sides. Each of those sides is at 90 degrees to the other. The second crystal shape is described as rhombic. With a rhombic crystal, again, crystals will have 6 sides. But each of these sides will be at 60 degrees to the other sides. So it creates a rhombus shape, similar to a parallelogram. The third crystal shape is hexagonal. Hexagonal crystals have 6 sides to the crystal, creating a hexagon shape. With internal angles of 120 degrees. With some hexagonal crystals, the top of the crystal will grow to a prism shape or grow to a point, for example, quartz. Other hexagonal crystals, like corundum, ruby or emeralds, will grow hexagonal crystals that have a flat top. The hexagons tend to form the longest part of the crystal. The fourth type of crystal is described as being mammillated or reniform. Reniform means kidney-like. These crystals are rounded, bulbous. The mineral itself will resemble lots of solid bubbles of mineral, but they have very distinctively curved surfaces. The fifth type of crystal form is foliated. Foliated crystals are arranged in sheets, parallel sheets, which will often break apart, but we get this sort of very flat crystal form as a result. The final crystal form is columnar. as the name would suggest, columnar crystals grow in columns. But these columns will be rectangular in shape. Some of these columns will grow to a prism, so a point at the top. Others will be flat. This ends the audio description for crystal form or habit. This is an audio description of the cleavage of minerals. It's for GCSE Geology, Theme 3, page 6 of the workbooklet. Cleavage is how a mineral will break. The way the elements are put together within the mineral can create surfaces where the bonds are weak. These are the surfaces that minerals will break along if they get hit with a geology hammer. We call them cleavage planes. What we look for within cleavage planes are regular, repeated, flat surfaces within a mineral. There are different types of cleavage. We can see what we call cubic cleavage. Cubic cleavage will have 3 planes of cleavage. So these are 3 directions in which the mineral is breaking along a flat surface. Any surfaces that are parallel to each other are counted as one surface. So in a cubic cleavage, we have 3 planes of cleavage, 3 directions that the mineral will break, all of which are at 90 degrees to each other. The second type of cleavage we look at is called rhombohedral cleavage. This is where the cleavage breaks to form rhombus-shaped surfaces. So again, like cubic cleavage, we have 3 directions. So 3 lots of parallel flat surfaces. However, with rhombohedral cleavage, each of those planes of cleavage are at 60 degrees to each other. The final type of cleavage is basal cleavage. Basal cleavage is where we have only one direction of weakness. The result of this is the mineral will split into parallel sheets, all running parallel to each other, and can create a very distinctive mineral form. We can also describe the quality of the cleavage. If we get very regular, very flat surfaces, we describe that cleavage as being good. If the cleavage is a bit irregular and we get a slightly rougher, less flat surface, it could be described as poor. This ends the audio description of cleavage. This is an audio description of mineral fracture. This is GCSE Geology, Theme 3, page 6 of the workbooklet. Fracture describes how minerals will break if there aren't any regular weaknesses within the chemical structure. This property is much less important for identifying minerals than cleavage. There are three terms that we often use. Uneven fracture is just a rough surface. There's no pattern to how the mineral breaks. This happens where there are no weaknesses within a mineral. A Hackley fracture describes the extremely rough way that a metal might break. We very rarely see a Hackley fracture. Where we do, it will be in metal ores. The final type of fracture is called conchoidal. This happens in hard, glass-like minerals. And this is the same way that glass breaks. Along the surface of breakage, we'll find semicircular ridges running away from the point where the mineral was actually hit. It creates, if you like, a shell-like structure, which is what conchoidal means. This is the end of the audio description of fracture.